Good afternoon. Today I'm going to take you through the steps required to convert an ODB++ file, which describes a printed circuit board and the components on both sides, into SolidWorks. And we're going to import it using a program called NETEX-G. NETEX-G will read the ODB, it'll do a lot of conversions and processing, and it'll produce an intermediate file called 3DI, and then we'll load that 3DI into SolidWorks using a plugin. You can see what the ODB looks like. It's a multi-layer board. In this case it has 8 layers. It's got components on the top and components on the bottom. It has solder mask and probably a silk screen and things like that. So you're looking at this. It has quite a few components, including ICs, various connectors, and many chip components. So our goal is going to be to keep the file as small as possible, also to preserve all of these mounting holes and any cutouts in the board, because if you're doing some kind of mechanical fit and function, that's what you actually care about. Okay, I've started up my NETEX-G program, and I'm going to use the File Import ODB option. I'm going to select my ODB file, and here's the file that I want to load. Alright, it scans the file and it gives me a list of all the layers. Now, because I'm doing a mechanical fit and function, what I'm going to do is I'm going to turn off some of these layers that aren't useful for that. I'm going to turn off the solder mask. I'm going to keep the top and the bottom conductor layers, and I'm going to keep the components on the top, components on the bottom, and the drill and the routes. Everything else I'm not going to bring in, because I want to minimize the amount of data I'm bringing into SolidWorks. Okay, you see that I've only brought in the top and the bottom, and I have one dielectric. Now what I need to do in this case is to change the value of that dielectric so that it actually reflects the true thickness of the board. Right now it's showing as 10 mils, and I removed, say, 7 layers, so I'm going to make that 8. But you can make it whatever you need to get the correct thickness of the board. The other thing I'm going to do is I'm going to tell the program I don't want any of the vias, but I do want any mounting holes, say, that are larger than, say, 0.1 inch in diameter. So that'll filter out a lot of data that I don't need, and it'll keep the data that I do want. Some of the other things is I want to make sure that any route layers I've imported are used to cut through the data, and I want to, I don't need to circularize my data here, actually. And my output is going to be called 3DI for step, and I do want my dielectric bodies. That's pretty much all I need to do, and now I just click execute. So the program's processing. What it's doing is cleaning up a lot of the layout data and creating the geometries that will be extrudable in SolidWorks. That's a very critical part of what we do here. Then it stacks them all up. Okay, it's done. It's produced what we call a 3DI file, which we're going to take a look at. Alright, on the left you can see the 3D version that we took from the ODB. There's the bottom. And on the right you can see the original ODB data, and you see the 2D outlines of the components, and you can see they've been extruded in 3D by the height that's been assigned to them in the ODB file. So this should give us a pretty accurate form, fit, and function. You can see where the holes are. These actually aren't mounting holes here, though they look like it. You can even see some of the routes that were cut out of the board there. Now our goal is to get this into SolidWorks. The way we're going to do that is to use a plugin called Read 3DI. Alright, there's a plugin Artwork supplies called Read 3DI, and you simply select the file that you'd like to have. And there's a couple of settings, and then you just click Import. This is a fairly big file because the top and the bottom metal layers have a lot of information on them. I'll cut out the time it takes to do this and report it afterwards. Alright, there we are. You pan around, you can zoom and see that it's got the top and the bottom. There's your single dielectric in between. There's your holes. That's pretty much what you have. It's organized into 4 different parts, one for each layer, M1 and M2, one for the dielectric in between, and one for the component top and component bottom. That's something you can now use to do a form, fit, and function. It used basically 2 tools. One was our NETEX-G to process the ODB and convert it into 3DI. And then the second was the Read 3DI, which is a plugin, and this plugin is available on SolidWorks 2010 through 2014 in 64-bit versions. Thank you.